Hello. Wow, that actually worked. What did you think of our fantastic sting then, folks?
Fantastic.
Okay, welcome to the first ever Cloud Natives UK. I'm super psyched about this. This has been about 2 years in the planning to pull this thing together. It's a virtual collaboration between the CNCF communities across the UK. So that's Cloud Native Manchester, Cloud Native Glasgow, Cloud Native Edinburgh, and Cloud Native Wales. Together, I guess we represent about 3,000 folks in the Cloud Native community in the UK. For those of you who don't know me, I'm Matt Jarvis. I'm a developer advocate at Sneak, and I'm co-founder of Cloud Native Manchester and Cloud Native Edinburgh. And I'll leave my fellow hosts to introduce themselves. So Nick, do you want to tell folks who you are?
Hey folks, I'm Nick. I work as a consulting engineer for SUSE by way of Rancher. I'm also a co-founder of Cloud Native and Kubernetes Manchester. And also because I've moved around quite a lot, and clearly my accent isn't a Scottish one, although I now live in Edinburgh. I'm a co-founder and co-organizer of Cloud Native and Kubernetes Edinburgh.
Awesome. Guy, do you want to say hello?
Yeah, I'm Guy. I'm based in Glasgow. I'm a software engineer at Skyscanner. I'm responsible for container platforms, Kubernetes, and still some ECS. And I'm one of the organizers of Cloud Native Glasgow.
Awesome. Adrian.
Hi there, everyone. I'm Adrian Moat. Through the day, I work as Chief Scientist at Container Solutions, where I do sort of our labs and open source projects. I'm also involved with Cloud Native Edinburgh and also the Docker meetup, which I think there's probably some people here that also have been to the Docker meetup in Edinburgh.
Awesome. And Lewis, last but not least.
Well, I like to think that you save the best till last, but as most people will know it's leave Lewis till last. So hey everyone, I'm the co-founder of Cloud Native Wales. I'm based in Cardiff. Day to day, I'm the head of training at Control Plane, hence that, there we go. And yeah, just really looking forward to today and all the talks that we got lined up.
Awesome. Awesome. Thank you, Lewis. So throughout this evening's proceedings, we'd love to hear your comments, thoughts, questions. You can put them in the comment section on YouTube, and we'll make sure we get to them. And I just want to remind everybody that we obviously are operating under the CNCF's Code of Conduct. So please respect each other and generally be nice. So I'd like to introduce today's very special guest, joining us all the way from New York through the magic of technology. He's a CNCF Ambassador, long-time contributor to the Cloud Native community, runs open sourcery at Sysdig, and he's the host of probably the best Cloud Native podcast on the internet. It's Dan Papandrea. And I've even got a super.
Everyone, welcome to the PopCast.
Hey, Pop, how are you doing?
Jarvis, you want a job? That was amazing here, for God's sake. Wow. Thank you all for having me on.
Cool. I'm very glad you could join us. It's like I said, it's been a while trying to get this this big Cloud Natives UK community together. So we're really glad that you could join us. So I know you're going to give us a talk a bit later on, but maybe we can start and just have a little bit of a chat. So I always like to ask people, how did you get into this Cloud Native thing?
So I worked for an investment software company in the States for a while. Prior to that, I was at Comedy Central Television Network, and I started Mac Tech Support. And at this investment software, it was a in-memory database that extrapolates data through something called SOAP, if you all remember that. God, I'm old. And so like we had this in-memory database, and these are kind of the beginnings of like big data and all those types of things. And so then later on in the career, it was like, okay, Solaris was really expensive. So it was like, okay, what can we do? And we virtualized this and put this in, this compartmentalized kind of thing. So then people could demo it and all that. And then we decided to go to the cloud. And what the cloud was at that point was configuration management and all of that fun stuff. And I was like, yeah, this is not where you take your instances on-prem and you move them to cloud. That's not the right thing, right? So I was like, okay, I want Mitchin to do something. So I joined HPE. And at HPE, I was the first Docker certified sales professional. So I was the first one at all of them. Because I saw that technology, I was like, you know what? This is where I need to be. I love this technology. It's fantastic. I was there for a year and a half, and then I moved into do cloud native work with Sysdig because I saw things like Kubernetes, Docker Data Center at the time, and Mesosphere. And then once I saw Kubernetes, I was like, this is not only an amazing technology, but as we all know, the community, is untouchable. And so that's kind of my history in cloud native.
Awesome. I know folks are always interested in how people end up in these places. I mean, what kind of gets you most excited about cloud native these days? About what are the interesting things in the ecosystem at the minute?
Bare metal deployments. K3S is fantastic. Obviously, eBPF, what we're doing with Falco and all of that fun stuff, and just overall security. I think, eBPF is something that I think you can do so much. And there's technologies like, Cilium and Keen Volk. And there's also, once people kind of see the potential of it, to me, it's a no-brainer, amazing technology. So eBPF is fantastic, but also like multi-cluster things are really cool. And I'm really, really love what's going on from like a WASM perspective with like service mesh. So like companies like, Solo.io or Tetrate, it's like a year and a half, 2 years ago or something, it was like, oh, what is Kubernetes? Now people kind of understand and can use Kubernetes, but now it's like service mesh. Okay, how can we put service mesh and ingress and all of that? So it's going to be a very interesting space in the next year or so.
Yeah, I agree. Okay, well, we'll come back and talk to you a little bit more throughout the show, but let's make a start with the first lightning talk. And this is a cloud native Wales one, Lewis. So I'm going to leave this over to you to introduce, and I'm just going to drop a few folks out here for the minute. Lewis, over to you.
Great. Well, thank you for this honor of having the task to introduce our first lightning talk. Might see him down there, but yeah, so you might know him as the YouTube sensation Salman Iqbal, as you can see by his handle there. You might equally know him as the co-founder of Cloud Native Wales, Salman Iqbal. But to me, he'll always be a liability, but most importantly, a mate of mine. It is Salman. So hey, Salman, how you doing?
Hey, Lewis, thanks for the great introduction. I'm doing well, thanks.
That's
exactly how I introduced myself.
Okay, do you want to share, Salman?
Yeah,
and
I am going to do the technology thing and share it.
And we'll disappear.
Okay, I'll share the screen. Matt, I'll hand it over to you.
I've got so many buttons here. I found it. Okay, we're there, and I'm going to get rid of myself. So we'll speak to you in a minute.
Thank you. Hey, everyone. Welcome to the first ever Cloud Natives Wales, Cloud Natives UK. Really, thanks to Matt for putting it all together. Thanks for all the speakers. Thanks for Dan Pop for joining us all the way from UK. And thanks to all of you. Today, we're going to talk about, in my lightning talk, what happens when you delete a pod in Kubernetes. It is important. I know it might seem like there's a lot of detail, but it is important to understand what that is. Let's get started. My name is Salman Iqbal, as Lewis mentioned. This is one of the cheesy screenshots I have to do for my videos. And I work as an MLOps consultant. Currently, I'm working for Appvia, and I'm also a Kubernetes instructor with LearnK8. I also, together with Lewis, run Cloud Native Wales. That's where we connect with the communities. It's kind of cool. You can also get in touch with me on Twitter at Salman Iqbal, but perhaps the better way to find me will be in the comments section in YouTube. I started a YouTube channel not too long ago. You can find me there on Salman Iqbal. I kind of make short videos explaining some of the concepts of cloud native technology. So far, I've only made videos on Kubernetes, but there's some more videos coming on machine learning and such that. So yeah, just check it out. You can follow me on Twitter at SoulManicBal. And yeah, like and subscribe, whatever the link. I don't know how it works with StreamYard, but just give it a go. You might all be aware of what Kubernetes is, and it allows us to deploy and manage applications that run in a container. Usually what we have in a Kubernetes cluster, we have a control plane, the one that's got Kubernetes on it. This control plane is in charge of deploying your workloads onto worker nodes. And how we deploy workloads is we containerize them. Everything is containerized, and then we deploy it. The way Kubernetes deals with these containers is it deals with pods instead. And pods is just a collection of containers. And what can happen is sometimes if a pod gets shut down, the traffic could be interrupted and you could not get a response back from the cluster that you're hoping to. So let's have a look and see how it works. So imagine we have a user. Let's call this user Dan. And the user is happily accessing, this yellow website. And the website has 2 replicas running because, perhaps you want a bit of a load balancing there happening. So sometimes the user gets a response from one pod, and at other times the user gets a response from the other pod. And nothing out of the ordinary, just our user Dan happily clicking away and watching the yellow page with pleasure. Some people do that, and Dan is one of them. Let me introduce you to our main perpetrator, a man who inspires me a lot, and a lot of other people as well on a daily basis. Thanks for that, Lewis. However, you might not know that this man loves to cause Kubernetes misery in the name of security and chaos engineering. If you do not believe me, watch this video on David McKay's YouTube channel, where David is fixing a broken cluster that Lewis has broken. You can check it out on Roll Code, like and subscribe to him. And also like and subscribe to Pop's channel. PopCast is a pretty awesome channel. So let's say Lewis comes up, he's here to cause some misery, and he says, I'm going to run kubectl delete pod 1. And folks, that command deletes the pod that our user is connected to. Now, straight away, you might start to think, what happens to the request that was sent, right? Will it be dropped? Most likely. We just deleted the pod. That's not an ideal situation, right? Let me give you an example of another scenario where you could potentially drop traffic. Let's have a look at another scenario. Let's say as a part of a deployment, we have running 2 replicas of version 1 of the application, and you want to upgrade to version 2 using this rolling update. Because we want 0 downtime, in a rolling update, Kubernetes spins up a new pod with a new version. We call it version 2. Once the pod checks have passed, it stops and deletes the old one and replaces it with the new one and attaches it to the service. If the old one was still serving some traffic, that traffic will be dropped. Sad times, right? And Kubernetes updates all the pods in the deployment. If there was some users being served, the traffic is gone now. Well, the problem isn't the promise of Kubernetes that there will be 0 downtime, right? The rolling update helps us that. In this scenario, it doesn't look like it. And you might be thinking now, what do we do? What do we go ourselves into? But before we can talk about what we can do, let's have a look at what actually happens when the pod is deleted. And hence, that's why it's important to understand perhaps the inner workings of what happens when we delete the pod. So let's see what happens when we run this command, kubectl delete pod 1. When you submit this request to Kubernetes, the request is received by the control plane, the one that's in charge. And inside control plane, there is a component called API server that actually receives the request. All the requests go via API server. Let's have a look at the flow at what happens to this request. What the API server does is updates this information that this pod needs to be deleted in the database that holds and stores the state of the cluster. That database is called etcd. And when that happens, there's something called an endpoint controller that gets notified. And that thing, this endpoint controller, is in charge of looking after the endpoint. An endpoint is just IP address of the pod and the port. And Kubernetes uses these endpoints to be able to route traffic to it. So now the endpoint controller has to start cleaning up because, we're removing one of the pods, right? And what it does is starts removing it from the services first. And service is just an abstraction layer that acts as an internal load balancer for the pods. If you want more information about what like services and endpoints are, I'll tell you what, you can check it out on my YouTube channel at Solmatic, but I've got more videos like this that'll explain it. But at this point, services are just like an abstraction layer that keep hold of, basically act as the internal load balancer for pods. So that change now has to propagate forward to remove the endpoints, not just from services, but from all other consumers. Everything has to go through an API server. So up next, the endpoint starts getting removed from kubeproxy, IP tables, ingress, core DNS. All these things hold endpoint information based on what kind of service is being used, and if there is an ingress or not. In a very simplistic way, all these things hold information about the endpoints to be able to route traffic to them. So while the endpoint controller does that, the kubelet is also identified. So while the endpoint controller does that, the kubelet is also identified of the change. And the kubelet is a binary that runs in each worker node and is in charge of starting and stopping containers. I want you to note that this flow is happening independently to the endpoint removal flow. And one does not wait for the other. So this is a separate flow. Among other things, kubelet is also in charge of running what's known as a pre-stop hook. As the name suggests, pre-stop hook allows containers to run given commands before it stops. Maybe you want to quit something before the container shuts down. Maybe you want to write something to the database before the container is stopped. And how do we define the pre-stop hook? With YAML files, right? So we love a bit of a YAML file. Here's a simple YAML file for a pod, and it's running an Nginx image. That's not much is happening. But what I can do is I can add this block at the end of the file, which starts with lifecycle. And for each container, I can define this lifecycle block in that which I can define the pre-stop command that I'd like to run. For example, you perhaps want to say goodbye before you shut down, right? Because it's common courtesy. Or perhaps you want to stop a process or write something to a file. So that's what the pre-stop command hook is used for. Let's go back to where we were. We're about to get to the finish quite soon. So after the pre-stop command is run, a SIG term is sent to stop the container. And the SIG term signal is used to terminate a running process. This starts a graceful shutdown period, which by default is 30 seconds. If after 30 seconds of this graceful shutdown period, the container hasn't stopped, a SIG kill command is sent by the API server to stop the process. Now, and SIG kill, as you know, causes an immediate termination of the pod, which means that if you were still processing some traffic, that traffic is dropped. Very sad times. Let's stick the two flows together, the endpoint controller flow and the kubelet flow. So this is the endpoint controller flow at the top, and at the bottom I've added the kubelet flow. And now I've added, both of these flows are happening independently. Perhaps you can already spot where this could start to be a bit problematic, right? Throughout the whole flow, the pod IP is still in use until it is deleted from everywhere, including kubeproxy, core DNS, and IP tables. But we know that a pod is only up until the end of a graceful shutdown period, and after that period, the pod is down. The traffic during this time will still flow to the deleted pod, but they won't receive any response back. Now we're in a sad situation. So how do we fix it? Now that you know what happens, you have most likely figured out what the solution is, right? And the solution is, let's just extend the graceful shutdown period. And it adds a bit more of a gap between the endpoints getting removed from all the consumers and deleting the pod getting deleted. So here's the answer. Let's just extend the graceful shutdown period. Now, how do we add that? Remember this our pod YAML that we saw previously? What we do is at the very end line, if you look at the very last line, we can add this thing called termination grace period seconds. If you know your container needs 2 minutes to serve all the requests, set to that. Sometimes you have to do a bit of trial and error to figure out the right value it should be. You can always start with like a higher number, higher value than you think you need, and to be on the safe side and adjust it later on. There's another way. If you insist, like Lewis in Chaos Engineering, you can use the kubectl CLI to delete the pods. You can actually add a grace period flag. And in this case, we're adding 120 seconds. So we basically extended that time. Let's say we want to delete a pod in a hurry because something bad has happened, right? What we can do is, some things have gone wrong. What we can do is add grace period equals 0. Imagine you cannot wait for too much damage. You can just stick that flag on in the end. So the grace period argument can also be used when you're deleting deployments with the same effect, of course. So that's what it is. You can extend it, you can remove it down to 0, and you can bring it up to 120. Now, let's do a quick summary. The endpoint controller starts deleting the endpoint from all the places it is stored. And while that's happening, the kubelet starts the shutdown process by initiating a graceful shutdown, which might not be long enough to process the requests already in the container. And new requests could still be sent to it. Fix for that is to increase the graceful shutdown period by adding termination grace period seconds. You can also use pre-stop hooks to run commands that close all the persistent connections, and just wait for all the active requests to drain. Hope that gave you a bit more of an understanding on what happens when a pod is deleted and how to avoid a drop in traffic. If you'd like to see more talks like this, check out my YouTube channel, and please consider subscribing to it. It's called @SolMyNickBar. All that is left for me to say is thank you for all of you to listening in, and thank you for Matt for organizing it, the first Cloud Native UK meetup. Stay safe, everyone. That's it from me.
Awesome. Thank you, Salman. That's super interesting. I really love those short form, explanations of things. I think, stuff, Kubernetes is kind of so complicated that often people don't really know what's actually going on there, right? It's kind of like black magic.
Indeed. Well, I'm a bit sad because I did put in a meme, which I didn't forget to export it. So you didn't get to see the meme, but I'll share in the chat later on.
Awesome. Thank you again. Okay, Nick, you want to take us through into our next...
Yeah, well, there was a short comment, a question in the YouTube chat from Sam Weston, who pondered if there's a way to get metrics on how often you're dropping traffic because of this. If your normal response time is less than 100 milliseconds, then 30 seconds should be plenty in theory, but hard to know.
I will respond in YouTube comments and stuff. I'm just going to read it, and we can chat.
Read it and process.
Yeah, definitely.
Yeah, fair enough.
Is that cool?
Cool.
Okay.
There's a good amount of banter in YouTube, and it's easy to lose track of the legit questions.
Awesome. Thank you again, Salman.
Yeah, thanks, Salman.
Thank you.
Cool. Hey, Sandro, how's it going?
Hello. Hi. Yeah, very well. Great to be here. It sounds like it's a fantastic event.
Yeah, it's great to have you. So Salman's here as an AWS consultant Sandro is here from Manchester, or representing the Cloud Native and Kubernetes group in Manchester. He works as an AWS consultant for the Scale Factory. So yeah, super stoked that you could join us today and give a quick lightning talk on assessing EKS cluster security using KubeBench. So I guess with that, we'll hand it over to yourself if you're ready to get started.
Yeah, I'm going to share my screen, and you should be able to see my screen and the presentation. Can you just give me a yes if you can see the screen?
Looks good.
Right.
Okay,
yeah, excellent. Yeah, hello everybody. Thank you for having me at this first event, UK-wide event. It's great to be here. My name is Sandro. I work as consultant at the Scale Factory, a cloud infrastructure consultancy based in London. And today I'm going to talk about how to assess EKS security using a tool called KubeBench. So I'm going to cover this open source tool, KubeBench, that you can use to run security checks on your Kubernetes cluster. So not just EKS, but I'm going to focus on EKS. I also want to show you the Center for Internet Security Amazon EKS benchmark, which is linked very much with the checks that are executed in the KubeBench tool. And then I'm going to end up with a demo of the KubeBench, how to run security scans with KubeBench, and I'm going to simulate a security vulnerability in an EKS cluster. So to start with KubeBench, it is an open source Go application that you can download from GitHub, and it checks whether Kubernetes is deployed according to best practices in security. And it has a very close relationship with a document that is published by the Center for Internet Security. The Center for Internet Security, they publish lots of different benchmarks on security, and one of these is for Kubernetes. And I'm going to show you actually this document, and it's a very useful document to reference to. And in particular, I'm going to show you the one for EKS, for the managed Kubernetes cluster provided by Amazon Web Services. So you should be able to see the PDF. You can download it for free from the Center for Internet Security website. I'll put a link at the end of the slides. And this document basically shows different checks that are executed at different level of the different Kubernetes components, in particular at the level of the worker nodes, and there are all sorts of different checks, but also at the level of the policies, so things like service account, pod security policies, and so on, as well as, and this is typical for EKS, and managed services, so the relationship with other Amazon AWS services like ECR or IAM or KMS and so on. I'm going to show you just very quickly a couple of these checks, since we're going to see them in the demo. So for example, in this check, which is referenced by this number, which we will see in the report for KubeBench, is just ensuring that your kubeconfig file has got the correct permissions, not too wide permission. Explains you what the check does, and also gives you some remediation steps in case your kubeconfig file doesn't conform to this check. Then there is another one for the ownership, kubeconfig should be owned by root, and so on and so forth. So going back to my slides, just showed you the EKS benchmark, and now let's dive into KubeBench. So how can you install and run KubeBench? You can install it as an RPM or a Debian package within your worker nodes and run it, run the package, or you can also install it as a job in the Kubernetes cluster. I recommend run it as a job because it will run not only the checks for the worker node, but also the other checks that I show you for the policies and the managed services. And it maps really one-to-one with the CIS benchmark that I showed you. You can also run a subset of checks, and you can also select different checks to be omitted in case you identify some false positives, some warnings which are not relevant to your EKS cluster. You can easily customize this. So let's dive into the demo. This is a pre-recorded video because I wanted to stick with the 10 minutes of my lightning talks. So I'm also going to describe it more easily with the video. So I'm going to start the video, and I'm just going to show you I pre-created an EKS cluster into my AWS account. This runs on 3 managed nodes, which are basically running on EC2 instances. So very, basic setup. I'm not running anything special in here, as I'm going to show you here. So basically, the pods that I'm running is basically an empty cluster. You just have my kube system pods running. And these are the nodes, exactly what I showed you via the AWS console and running. So I'm going to show you now the job manifest file for running KubeBench. So this runs as a job and is using this image, which is published by an AWS partner called Aqua Security, but you can also build and create your own image and push it to your ECR. So if you want to be really on the safer side. And this is the way how you run the command, and is using the EKS benchmark that I showed you. You can also run a subset, for example, only the checks for the worker nodes by simply adding this parameter to the command. This is how you run a subset of commands. And you can also integrate it with AWS Security Hub. There is a file for this. So I'm simply applying here the job configuration, and I'm checking that the job has been executed successfully, which is the case, as completed. In order to look at the report, I have to inspect the logs, and I'm typically outputting the logs to a local file that I'm calling assessment1 that I can then inspect at leisure. So I'm opening the file, and here you can see all the checks that have been executed by Kubebench against my cluster. So you see in the section 3, which is the one related checks for worker nodes, I've got mainly pass. I've got one warning which might or might not be relevant for me. I got a summary at the end. Then I've got the checks for policies here. Since I'm not really running anything as an empty cluster, I've got all warnings. And then I've got the section 5, which relates to managed services, as I showed you in the PDF before. And then at the end, I've got also a summary for each section, but also for the total that you can actually use in, for example, in CI/CD. Now I'm going to make sure that every time you run the job, you finish the job and then you delete it and make sure that it is deleted, since you have to create a new job, a new execution of the job each time you want to run it. So now I'm going to SSH into one of my nodes, and I'm going to introduce a security vulnerability. So I'm running this in a public subnet. If my node's in a public subnet, if you run Kubernetes in production, it's always recommended to use private subnets. Here, for sake of simplicity, and also so that I can break it, I'm using this in a public subnet. I'm going to change my kubeconfig file, and in particular, I'm going to change the permissions. I'm going to give way to permissive permissions, and I'm also going to change the users, so the kubeconfig is not owned by root, but by a generic EC2 users. So if Kubebench works, it should flag this as 2 security vulnerabilities. So I'm going to apply again the job, so I'm going to rerun it, and I'm going to check that the job has been executed as completely successfully. And then I'm going to put the logs into a local file, output the logs into a local file. I just have to take the name of the job and then output the logs into a local file that I'm going to call assessment2 this time. And let's see what Kubebench flags. And as you can see, it has found 2 failed checks related to permissions and related to ownership, and also gives me some remediation steps to fix these security vulnerabilities. And these are taken from the PDF that I showed you. Also show at the end that these 2 checks failed, and you can use this output into your CI/CD pipeline, or maybe send these reports to AWS Security Hub, as there is a nice integration with it. I'm going to go back to my slides, and it's almost the end of my presentation. Just to conclude, if you have a Kubernetes cluster, and this, as I said, it applies not just to EKS, but to any Kubernetes cluster that you might run on a cloud provider, Azure, Google Cloud, or Red Hat, or your own Kubernetes cluster, not managed by you. Just give it a go. Install and run Kubebench and see what it reports, and also have a look at the relevant CIS Kubernetes benchmark. It's very interesting, really could help you to assess the security of your Kubernetes cluster. So that's the end of my presentation. I'm just going to give you a few links where you can find, download Kubebench, and a few other readings if you want to have more information on this topic and in general on security. If you have any questions, feel free, to ask. You can contact me via my employer, the Scale Factor. We are a cloud infrastructure consultancy, and we specialize in AWS and security. So feel free to contact us via Twitter, email, or via our website. And that's the end of my presentation. I'm going to stop sharing.
Once we finish bouncing each other around, that was awesome. Thank you, Sandro.
Thank you, Sandro. Awesome.
Yeah, good stuff. We had one question that came in, which was if you know offhand if KubeBench has a Helm chart that you can use to install it.
Yeah, I think it does. Yeah, if you look at the GitHub repositories for KubeBench, then you should be able to find something in there. I'm going to try to look at the specific link and then post it.
Cool.
Awesome. Well, I think that was all the questions. So thank you very much for joining us. I think KubeBench is a cool project. I think it's great. Folks, again, more interested in security. Not that I'm biased working for a security company, but all right, let's add some folks. So Sandro, thank you.
Thank you for having me.
Pleasure. Hopefully see you in person at some point again soon.
With some cars pasties.
Let's
get some free beer.
Go here. Right. Okay. Nearly time for the main event. Pop, welcome back.
I don't know if I'm going to live up to the expectations of those two, for God's sakes. Wow. You see, you all gave us the Beatles and Rolling Stones. Like, we gave you pizza and pop. I mean, geez, I don't know. We gotta step up our game, America.
I had a special treat for you actually, because I know how much you do appreciate pineapple on pizza. But
let it go, people. Let it go.
This was a new variation for me. This was pizza on a pineapple. So I'm kind of, I'm not quite sure.
I'd give it a go.
All about.
I'd give it a go.
I've never seen that before.
I had not seen that before either. I was doing some research for the show, and I was shocked. I was shocked. I've seen the cauliflower, but not pizza on a pineapple. That's just wrong in so many ways. Okay, right. Where have we got to? I'm losing the plot now. So I wanted to talk to you a bit about the PopCast before your talk. So, you know, I've done a few of these video things over the last year, but your output has been astounding. I think it's 58 shows in the last. Is it just over a year? Is it?
And I took a break, man, too. Like I took a little bit of a break, but yeah, I mean, honestly, if I didn't love doing it, like I wouldn't do it. Like you hear this pound blessed, but I am absolutely blessed. It's like what I wanted to do with this show is just kind of connect with this community, and I love every episode I do. I enjoy it, and everyone's like, "What's your favorite episode?" I'm like, every one of them. They're like my children. So.
Yeah, I mean, I was going to ask you that question, but I won't now. You've stolen my thunder.
The Plex episode this season actually was really well received. So if you all are familiar, like I learned a lot of microservices, through using Plex, and Plex is a multimedia kind of library sharing tool, right? And having him on was like a dream. But Kelsey, having the godfathers of Kubernetes, Sarah,
some awesome guests.
Sarah Novotny, again, like that Sarah Novotny is worth their weight in gold in terms of everything. But every single guest has been phenomenal. I've even had Gareth from Snick on, and Gareth was phenomenal as well. So,
yeah, I mean, being in DevRel at Sneak is a bit of a double-edged sword, because you're like, wow, Gareth Rushgrove works here, and then you're like, Gareth could do my job in a second far better than I can do it. So, I mean, what was the motivation for starting the show to begin with?
I enjoy being in front of end customers and being out in the community, and we have conferences, and we get to grab a beer, we get to, or non-alcoholic beverage if you're so inclined, but like you get to hang out with folks, and I wanted to have that feeling somehow. Right. And so I started talking to a couple of my friends, I was like, hey, Steve Augustus, who's, had a release lead. He's at Tanzu, and like, hey, you want to come on? And so we started talking, and then like, hey, Kelsey, you want to come on? And so it was like, it just started steamrolling, and it just, I enjoy just like, interacting with the community and also like hearing people's stories, and not just the, technical. I want to understand how they got to this point, and I think that that's also resonating. As again, my tagline is like, the connecting the human behind the code, but I feel that that's resonated because all day we're pelted with technical, which is great. It helps us kind of learn, but having to understand, what Kelsey's motivation was for one of his talks, or what Phil Estes' motivations for Container D and stuff like that. I mean, those are great. And I'm trying to piece together that story of cloud native through all the people we interview, and it's been, again, a dream. So
yeah, I mean, I think that's awesome. I think in this pandemic has really made us think a lot more about what is engaging for folks in the community, and I mean, I think sort of digging deeper into people's stories, and especially in that kind of chat format, is just so much more engaging than having lots and lots of talks. I think we're going to see a lot more of that even when things go back to normal in our conferences and things, because I think it's clear that people are interested in other people's stories, right? I mean, that's why I often ask people how they got into what they're doing right now, because I know there's a lot of our communities who are sat there going, well, how would I get into doing something like that, right? And you don't get to understand that unless you have those kind of chat formats. I mean, one of my favorite things at conferences used to be at the open source summits and Linux cons was always the fireside chat with Linus Torvalds. And I think we're going to hopefully see a lot more of that when we get back to in-person conferences as well.
I don't know if you all went to San Diego, but San Diego, every single night in KubeCon, it was like everybody was at that bar and everybody was grabbing a drink. And even if you're competing with somebody else, you were like, hey, let's talk. It's like, because we're all one big community. At the end of the day, what are we doing? The end users are the most important part of what we do. We want to be able to talk about, oh, this is cool, they're doing this, this, and this. And so to me, it's just like, it's a natural thing that the extension of this amazing community is being able to speak openly, understand their stories, and like you said, is connect with people.
Yeah, absolutely. Okay, great. Well, let's get you all set up for the next bit. I'm going to drop a bunch of folks out. Pop, do you want to share your screen, and I'll
Yep. Are you all seeing this okay?
Yep. I've got that. Too many buttons.
Oops.
Okay, let's get rid of Guy as well. Okay, over to you, Pop. I'll drop myself out.
No worries. Hello, everyone. So my name is Dan Papandrea. I'm the director of open source community ecosystem for Sysdig. I work on the Falco project. This talk is runtime security is like making biscuits. I'm using the Kings here, right? Cookies, but you need the right ingredients. Now, I've done this talk a couple times this year. I'm actually going to do it all this year, but I'm using different technologies and different integrations with Falco to kind of demonstrate the capabilities that you can have from a runtime security perspective. So your first ingredient is syscalls. And so if you look at syscalls, when you run a program, you are making system calls. System calls are how a program enters the kernel to perform some tasks. So if you think about applications, Kubernetes, OS, kernel, that interesting stuff, and I think we talked about this earlier, was integrating to something called like eBPF functions and all those things. Those are some interesting things that you can do and get a lot of visibility on. System call is the fundamental interface between an application and the Linux kernel. This is the man page for it. So again, having that underlying capability, that to me is an ingredient you would use. The second ingredient, well, kind of combined, is eBPF and the Falco project. And so what eBPF is it's basically in the past, if you wanted to make any updates to the Linux kernel to do certain pieces of functionality, you would have to contribute to the kernel code. eBPF is almost like a little window into it. So it allows you to run programs in the kernel space without changing your code or reloading a module. So, accessing kernel activity for stability or security, or it's useful for troubleshooting and security and all those. There's examples out there if you think of, Cilium, or some of the things that Kingvolk are doing, or like Tracy, for instance, from Aqua. Those are capabilities that allow you to introspect eBPF. And so Falco also lets you do that from the kernel syscalls perspective. So again, that second ingredient, like I talked about, syscalls are the underlying thing at the kernel to be able to do so. So what is Falco? So Falco is a CNCF Cloud Native Runtime Security Incubating Project. It was created by Sysdig in 2016. Detects unexpected application behavior, which I'm going to demonstrate in a second with a very lively demo. And we're the de facto Kubernetes threat detection engine. And so how we do this is, remember that magic system calls and eBPF. We use this to parse the system calls from the kernel at your runtime, asserting a stream against a powerful rules engine, and then alerting to you of what occurs. We've just donated to the CNCF, contributed to the CNCF, basically these two things, right? And so, Falco and Rules Engine was donated early last year, but 2 years it took us about a year and a half to package up the underlying linspect and SCAP tools. Those are the capturing and event parsing tools. These are now freely available for somebody to create on top. It's almost like an easy entryway into eBPF programming because you have these capabilities for event parsing and capture controls. And also we donated our kernel module capabilities in eBPF Pro, which we feel is useful for a non-blocking event collection. And so really useful if you want to kind of get a head start on it. But using Falco will allow you to kind of get a head start from a security perspective based on our eBPF probe. I want to talk to you about the architecture here. And this is where, again, when I'm going to show you the demo, I want to show you what occurs here. So what happens is if there's a suspicious event, right, we're using the probe to be able to tap into those two libraries that I talked about that have capture and or inspect capability. And then you can filter in those things, creating rules to alert to a suspicious event, like we're writing to Etsy or terminaling into a container, or even Kubernetes audit capabilities can be integrated as well. Then you can send out to syslog, file, standard out, shell, HTTPS, or gRPC, or you can use something called Falco Sidekick, which the thing I love about Falco Sidekick, it was an external contributor in France who created it, took like our standard, standard out syslog file and extended it with over 23 integrations. So you can see here, you can basically connect it to NATS or PagerDuty or OpenFAS or some of the other things, your Datadog or Prometheus. So we have that level of integration. So we ship a default set of rules, and I think again, if we talk about earlier, what Sandra was talking about, the capabilities with KubeBench was a really cool tool. Again, we kind of give you these out-of-box like integrations for like things like the MITRE ATT&CK framework or other things that help you like from a perspective of default rule set. You can extend that rule set, which I'll show from the demonstrations perspective. So the third ingredient. And here's a real world example. I want to show you where I have somebody that wants to steal these amazing cookies that our host here, Matt Jarvis, created. So let's go ahead and talk about that. So I'm going to go to my VS Code. And I've deployed a cluster using Civo Cloud. By the way, check them out. Smash the like and subscribe. Excellent tool. It's basically a K3S, managed K3S environment here that I've deployed this. Now, if I go ahead and go get pods, you'll see I have an Nginx controller and I have my lovely lemon Shrewsbury, which I found out that apparently they're named after specific areas of England. So you all are giving me an education, so that was pretty cool. So Matt Jarvis has this amazing cookie recipe, right? And we want to keep it safe. I mean, this is Mother Jarvis's amazing, biscuits recipe. So we want to keep it whole. So let's look at this. And we look at this is a standard, again, we talked earlier about YAML. Solomon talked about YAML capabilities. If you look at this, we see like we have an Nginx deployment, and we're seeing that it's writing to this mount path, this user share Nginx. I'm going to make this a little bigger so you all can see this, right? And so what I've done is I've already deployed get pods -n Falco, and it's a simple Helm deployment. And I'll show you, it's in one step. You can deploy this. Helm chart installment does all of these things, which I'll show you. And then I've deployed with a custom set of rules. All you have to do is, and this is YAML as well, is there's a rule called biscuits recipe tampering detector. And then detecting the description, there's a condition. And again, remember I told you about that lib capture inspection in the ingredients we talked about earlier, where we have system calls, where these are things where somebody's writing to a path like user share Nginx or what have you, right? Like we're writing in here. Then we can output that. That's the words that you see on the screen, and we can prioritize it and tag it, okay? So let's go ahead and do that. We're going to attack that pod. Okay, exec, right? We're gonna just try to move it. Cannot move it, uh-oh. And let's look at this. Do a refresh here. And we can see there's my cookie tampering recipe. This thing happened. So we can see this, oops. And I can double click in here. And I can see that, and this is, by the way, I've deployed Falco Sidekick UI for us to be able to see, and this is, by the way, brand spanking new. It's filtering through these capabilities. I can tag and see all of the events that happen. So remember that recipe I told you, there was that rule, biscuits recipe tampering detector, okay? And I have Sidekick deployed, and it's outputting to Slack, and I'm also using kubelets, which I'll show you an example of as well. But I have all the events that are happening. All of those things are things that are happening within the kernel. So I might be able to do something like this. Hold on, let me hide this. I might be able to do something like this, where I want to, hold on, sec. Etsy shadow. That's a sensitive file. I want to be able to touch that. I want people to know that I want to know that that people are attaching themselves to that. So I can see here, if I go to my dashboard, I can see, remember, set sensitive event. So if I click on this sensitive event here that happened in green, it's going to show me which process. There was that cat that just happened. Let me see if I can make this a little larger. And then this happened at root. This is showing me the command line capability. This is showing me the Kubernetes namespace that this happened on and the pod. So you have this visibility into what's going on. And you saw that the speed of the system call, when I did that attack of it, it's showing me that I've done that. Now, I'm going to show you my last example, which, by the way, remember, I have it integrated to Slack as well. So I have my friend Matt Jarvis over here, and I can say, Matt is stealing your biscuits. And Matt, being the upstanding person that he is going to go ahead and he's going to, deploy another deployment, which, by the way, he's using Snyk. And so he's able to make sure that at the, from the pipeline perspective, you're protected there. So shout out to you, Snyk, right? So now here's what I want to do here. I'm going to do something else here. I want to be, if I'm Matt, I'm trying to attack this, I want to maybe go another route. Maybe I want to start up another container, right? And so let's go Cookie Monster. I'm going to try to exec into that container. And let's see, oops. So I'm going to start up another pod. And this one is simple Alpine deployment, right? So, and that's deployed. So let me go ahead and just patch it. As you can see, it's running right now, right? Here's what I want to do. I want to go ahead and exec into that pod, and I want to cause some mischief. Because look, if I can't get into that file, and maybe I want to do something like that. So I'm going in, I've terminaled into the pod here, bashed, and let's just see here. Oops, yeah. Try this again. Oops, so let me try this again. I'm going to exec into the Cookie Monster pod, -n default, --dash bash. Oops, shell spring. And let's see, we're still running here. So basically, let me just see here, exit, and I'll see if kubeless was running. You get ns kubeless. All right, pause. Just bear with me one sec. Alrighty, see, this is where we use a demo that I've already recorded. So let me just kind of show you what's up here. Let me share this here. So we can see here again, this is another example that I have using KNS where I have Sidekick and the UI running. So apologies about that. And so I have the UI and Sidekick running as well. And so I'm trying to exec into this pod here, right? So here's my logs here that's going on. It's just showing me that kubeless and the UI is running. And I'm going to, oops. Let me go here. Sorry, this is the one I want to use. Just bear with me a sec. There we go. So I can see I have one executed and going. And I want to go ahead and show you that if once you terminaled into it and execed into pod, I was able to kill that container. So let me go back to my slides here. Just bear with me a sec. Yeah, this is fun. Losing all my screens. There we go. So again, this was an example where we can also respond to threats using kubeless, OpenFAS, Knative, or Lambda. So it doesn't have to be where you're going into, only having it output to something. You can also trigger something through the outputs of Sidekick. If you want to, kick the tires right now, it's very simple. Just use a Helm repo and then install using Helm. It's very, very simple to be able to do so. And if you want to contribute to Falco, here's some capabilities. If you look, you can get started in falco.org, check out the Falco project in GitHub, get involved in the Falco community. There's all this details. If you're looking to contribute not only from a core engine perspective, but in other capabilities, you have that as well in terms of rule set or documentation. So I am going to stop for any questions.
Let's just add some folks back in here. I'm sure somebody will have some questions. Right, we've got one to start with from the audience.
So you have the ability to actually, the software itself allows you to kind of output to look at this from the capability of understanding what's going on in your environment, because you can't audit these things of what if somebody's looking not only at the container level but also at the host level. But you can integrate like I showed earlier, where there's a capability to integrate with something like kubeless or Knative or Lambda functions using the Sidekick. Now, if you want more, capabilities in terms of, blocking things or contextless capability, then you would look at Sysdig's commercial tool, which, I think, you can look at that from a free trial perspective as well.
Awesome. And we've got another one here.
Absolutely, yes, it can. And by the way, we're working with the Cloud Native, the Cloud Event and the Knative team that have built this integration as well. So that's one of the choices. If you look at Falco Sidekick, that's there as well. But that's a PR. And if that's something you want to, extend that capability, please feel free to join, falco.org/community and, and join and contribute to that as well.
Awesome, thank you, Pop. It's a super interesting area. I mean, how much are you seeing kind of folks put in place automation pipelines and stuff around this kind of stuff these days?
So in terms of adoption, it's been phenomenal. I mean, we were included in the CKS test, this is Certified Kubernetes Security Admin, and I've seen I've seen basically the uptick has been incredible. I mean, we went from like 12 million downloads and from the November timeframe for our Docker polls to over 24.7 as of this morning. It's incredible, but also I think the community's been phenomenal in terms of just like, external contributions, like, OpenFAS integration. I wasn't able to demo that today, but like that's something from the OpenFAS community is able to do. The Knative crew has been doing, like the AWS has contributed, like integrations to, things we're doing with EKS, and also like even our backend deployment using Prowl has all been engineered using like, AWS, and IBM folks like helping to build the build process. So adoption's been phenomenal, because if you think about it, and we talked about this in another talk, Matt, you remember, it was basically like, if you have, from a software supply chain perspective, it's great to have that capability from build and that, but when it's running, being able to see that introspection, you notice that it was instant for me to, when I did that Etsy, I was able to get that thing, or when I tried to edit, the HTML there, because I had that rule, it was a simple nomenclature for me to understand that, okay, that was user share engine X. Now I know that, Matt's the cookie thief. I can, either alert or trigger something like, a Knative function or a Lambda function or something of that. Think of the possibilities there. You could have a function for everything, do a mem dump, all of those things. You can create a whole set of functions if you need.
Yeah, absolutely. And I think, we've talked about this before, but I think security around cloud native is just super interesting at the minute. This, people are really taking it seriously, and there's lots of innovation happening across the board in security right now. I'm preaching to the converted here, given that 3 of us on this call all work for security companies.
You know that the integration too is also the CSPM capability. So things like if somebody's touching an S3 bucket, having that all amalgamated in one place, you'll see a lot of that where we just made a blog announcement where it was basically Falco as rules determiner for hey, somebody's touching an S3 bucket, so you can create verbs and all of those things using the same kind of rules engine that you would for a syscall level introspection. So having one common place to do that, I think it's pretty rad, to be honest with you, to use an American term.
Awesome. And we should have a quick plug for David and Lorenzo's book on eBPF. If anybody is interested, I can highly recommend it. I'm halfway through it, and it's super interesting.
Lorenzo, Leo, and again Thomas. Both, we have 2 Leos, and Thomas, the guy that basically created Sidekick. He's actually doing the French version of the Cloud Native Meetup right now, and so it's just been phenomenal. It's a great community, and it's we've tried to make it just like the Kubernetes community. We want people to come in, feel welcome, feel like, we instituted something called the Contributor of the Month, where if somebody come in, this one person, he's amazing, his name is Frank. You see that new UI that we showed you from Falco Sidekick? He created that in a matter of 2 weeks. He's a JS expert. And it's just he came in out of the blue, and we were like, you know what? Everybody in the channel was like, yeah, +1. That guy should be the Contributor of the Month. So it was just it's beautiful, it's just awesome having, seeing people doing these. We're all in various SIGs, we're all in various working groups, and just, if you contribute, giving back to those people, saying thank you is the best thing you can do from a community perspective.
Absolutely agree. And I did put the banner up while during your talk, but Pop was very kindly organized for some Sysdig swag for all of our community. So if you want to grab yourself some, you can. I'll leave the URL up on the screen there, and I guess we'll start. We'll move on. Who's our next speaker? Adrian, I think you're introducing our next speaker, aren't you?
I believe so. First, I actually want to say I think Dan's swag is pretty sweet. So go and check it out. Actually, yeah. So next up we have Dan Gora, who is representing Cloud Native Edinburgh. Dan is a senior cloud security engineer at CloudReach. He's going to be talking on attacking Azure identity. So please take it away, Dan. Do remember, all of Scotland is behind you.
Oh, that's good to know. Even though I'm not Scottish, but I'm very proud to present.
You're representing us today.
Awesome. Okay. And let me just share my screen and get started. Okay, can everybody see my screen? Awesome. Great. First of all, thank you very much for letting me just show you some of the really most relevant attacks affecting cloud identities. And if we think about one of the recent breaches around SolarWinds and Sunburst, cloud identity attacks are one of the most prevalent ones, resulting in breaches of the Fortune 500 companies. So this is something I want you to show how to attack it and how to defend from it. So my name is Dan Gora. I'm currently Senior Cloud Security Engineer at CloudReach, and I'm focusing mostly on multi and hybrid cloud environments, and that specifically around Azure and AWS. I'm also very passionate about DevSecOps, basically shifting security left wherever possible in whatever we do, and also making sure that all our customers' workloads are running securely inside cloud-native environments. And if you have any questions in regards to DevSecOps or cloud-native security, just ping me on Twitter. What we're going to talk briefly is just about the relevance of credential access attacks, especially talking MITRE. And then we're going to have a deep dive into the managed service token abuse attack. We're going to talk about mitigation techniques and then conclude this with a quick review. So first of all, if we talk about credential access attacks, we have to think about the MITRE ATT&CK metrics. And Pop mentioned that briefly, that frameworks like the MITRE ATT&CK metrics really help us understand the attacker's perspective. So if we think about MITRE, we have tactics, techniques, and procedures. In terms of the tactics, for credential access, we have the sub-technique, which is called the stealing of the application access tokens. And that usually occurs in the later phases of the MITRE ATT&CK chain. So that's something we call the post-exploitation phase. So that's our focus, and also something that we've seen in one of our customers' environment occurring and creating a lot of damage. And in particular, we talk about the MSI token abuse attack, and that's basically related to a misunderstood concept in identity environments in Azure, which is called a managed identity. A managed identity is essentially a service in Azure that allows you to talk to other services. So it's basically connecting, or the connecting identity. That also relates to the service principle, which is basically similar, but this is more tied to specific cloud-native services. Let's just talk what we've seen in our customer environments happening, and just talk you through the attack path. So first of all, what we've seen is that those token abuse attacks usually start with a code injection into a cloud-native service. In our case, that happened with an Azure app service, but could be the same for a Kubernetes cluster. With that case, that the attacker was able to perform remote code execution or server-side request forgery, and was then able to get operating system shell access and forge resource access token via the local token service endpoint. With this one, the attacker was then able to get a lot of information about adjacent services inside that environment, and essentially was able to access key vault secrets and related access keys. So the key vault is essentially the service in Azure that allows you to store passwords. With this in mind, then the attacker was able to grab those credentials from the key vault and log in with those elevated permissions, because they had I think global admin permissions attached, as well as a CI/CD deployment user that essentially allowed them to take over the whole tenant and all the workloads, including cloud-native workloads like Kubernetes. So let's now walk you through how this actually occurred and what happened. First of all, what we can see here is a simple cloud-native application architecture. We have a Azure App Service running in the front as a front end, and also on the back end. Then we have the database connecting to that app service, as well as the key vault that is associated with that app service for authentication purposes. So in our case, there was a financial processing application used for having workloads around financial transactions. That app service also had a token service endpoint attached, and the managed identity that ran on that service, as well as the Azure Active Directory that was connected to that managed identity. So what we've seen is that the attacker was essentially able to inject code into the Azure App Service, and especially in the context of that workload, and was able to perform operating system shell commands. With this in mind, the attacker was then able to have code operating system capabilities on that machine, and was able to forge the resource access tokens, or the OAuth 2.0 access tokens, on that token service endpoint. With this, the attacker was then able to basically forge the access tokens for the key vault and retrieve the key vault secrets from that particular service. In that case, the attacker was actually had access to a CI/CD deployment user that was stored inside that key vault, and had subscription owner permissions on that particular tenant, which essentially allowed them to take it over. What we've also seen was that the key vault also had a emergency break glass user account attached that essentially allowed the attacker to grab those credentials and log also in with a tenant with even higher elevated permissions, which is the global admins. So essentially, that was game over for that particular tenant, and create a major breach. So now that we've seen that how important those credential access attacks are, let's just talk about the potential mitigation techniques based on Microsoft best practice recommendation, as well as from our experience from what we've seen with customers. First of all, the most important part is least privileged resource-based access control. Understand your identities and tie them down wherever possible. In that case, what we've seen was that that application had access to a key vault with emergency break glass user credential as well as a CI/CD deployment user, that was not really necessary. But we've seen this quite commonly, that this is misunderstood. You know, it's a deployment user, so just give them any permissions inside the tenant or the subscription. Another important thing is enabling auditing and logging activities. Make sure that especially managed identities and service principals are continuously monitored and also integrated into your security monitoring solution. And also a brief note on managed identities, that's something that's not been supported for a while, the activity logging. So now it's supported by Microsoft, and definitely make use out of that and ensure that there's auto trail for whoever logs in with a service principal or managed identity. Another important piece is threat modeling. Understand your application, the input and output paths, create a model and understanding, and things like the MITRE attack metrics can help you a long way with understanding the potential threats of that. And basically create a document or a diagram that just shows the trust boundaries between your systems. And finally is multi-factor authentication, as well as conditional access. In terms of multi-factor authentication, in our case, if the emergency break glass user would have had multi-factor authentication enabled, that breach wouldn't have occurred, at least even though the attacker would have gotten access to that credentials. As well as with service principals, just make sure you enable conditional access policies inside the tenant and only allow service principals to log in from certain locations. So let's do a review of what we've seen. First of all, we've seen how important credential access attacks are, especially when we think about the MITRE attack metrics as part of post-exploitation. Then we have seen the managed service identity token abuse attack that essentially allowed a threat actor to grab API keys to perform operating system commands and log in with those stolen credentials inside that tenant and essentially allowed them to take it over. And finally, we talked about the mitigation techniques. And that's something I want you to take away is wherever possible, when you run cloud native workloads or any workloads with identities attached, make sure to understand them, make sure to perform threat modeling wherever possible of your application, tie down your identities, especially managed service identities, also enable multi-factor authentication, and as well as conditional access policies. That goes a long way of protecting yourself from the bad guys. With this in mind, really glad just to show you this from the experience that I've seen with some of the customer environments. Very happy to talk about this further if you have any questions. Otherwise, just with this knowledge in mind, go ahead and elevate your cloud security. My name is Dan Gora, and yeah, if you have any questions, just talk to me on Twitter or talk to me. Yep. Thank you.
Fantastic. Thank you, Dan. That was really interesting. I think it's you know, once folks start understanding that the majority of these actual exploits come down to a combination of application vulnerabilities and infrastructure misconfiguration is a kind of key point to think about, isn't it? You know, all of the really big hacks recently have come from that. Yeah.
And we've seen this especially in hybrid cloud environments. So both running cloud native services as well as like identities that have been connected to cloud providers like Azure or Azure identities. Yeah. And it's just important to understand the attacker's perspective in order to defend yourself.
All of these things together that we showed, right? Kubebench, identity, Falco, Sneak, all of these things. There's Kubernetes is coming out of the box protected. Okay, it doesn't. We all don't kid yourself, right? If you put all of these things together in an erudite way, you will be, much more protected than you were like just taking things out of the box. It's not, in the past it was like, oh, I just deploy, a kubeadmin and I go. It's like, no. Especially if it's production and it's, public facing, having these safeguards in place, having a platform, for instance, that's able to do that is also super useful. So again, all the great talk, Dan. Just props on that. Really good.
Thank you.
Yeah, great stuff. Okay, so I think Guy, you're going to introduce our last lightning talk of today. Let's just drop a few folks out here. Thanks again, Dan. Let's bring in James. Hello, James.
Hi there. Good evening.
Hello.
Okay.
as you said, we've got James up last for the Cloud Native Glasgow meetup. So James is, a techie and a world record-breaking athlete, which sounds fascinating. Competed in the race across America. He's also a customer engineer at Google and an evangelist of Google's innovation in Cloud 2.0. And he's going to be talking about multi-cloud. And I'm sure this won't be controversial at all, but why it's a sensible strategy and how to get there.
Yeah,
Okay.
pick the easy subjects, hey?
James, if you want to share, I will get you all set up and then leave you to it.
Get the right one. Okay. So yeah, thank you for having me. The athlete part has got nothing to do with my work at Google, so I won't be taking up a lot of time. Certainly not as much as I do when I'm riding my bike. So this is a lightning round, so I'll try to keep to the gist of that. So why build for multi-cloud? And cloud is quite relevant. Coming from Scotland, we know lots about cloud. We see them every day. There's rarely a day that we don't see about anything about clouds, but maybe we're going to talk about the other type of clouds. So I'll just start with a quote. I took this from a customer quote, but I took the customer name off just now, but this is a genuine customer quote. So it says, "We believe that the advantages of using multi-cloud platforms heavily outweigh the challenges. Over time, we learned that the benefits have gone beyond extended capabilities, lower costs, and improved performance." So yeah, there is added overhead to have more than one cloud provider, but I'm hoping to try and illustrate the advantages of having that. So we expect our cloud providers to be there all the time, to be as cheap as anything, to be as secure as they could possibly be, to provide tools that we wouldn't have otherwise had, and to give us the very best in terms of the latest technology. So we do demand a lot from our cloud providers. But maybe you're in a position where you have one cloud provider, you're already there, but is it giving you everything that you need? Is it holding your business back, or are you happy with it? And more these days, people are looking to say, oh, well, maybe we need more than one cloud. So just take a step back and say, hey, maybe we should just look at these as component parts, any of which could fail at any time. And of course, we've been used to the on-prem data center and how to secure it, how to make it highly available. And as businesses are moving to hybrid cloud and into using the cloud more and more, like in the cloud native environment, maybe we're just assuming too much that one cloud is just always going to be there. And when it isn't there, it's a bit of a surprise. But if you took a step back and said, hey, maybe look at each individual component part and assume it's going to fail, then what can we do? What should we build a solution around that? So why look at multi-cloud? Well, if you look at the individual cloud providers, they are all different, maybe subtly different, but they are different. They have different tools or different flavors of those tools that may be better for your business if you are free to choose across multiple cloud providers and rather just the one that you're using today. And that maybe is as a great advantage if you can pick and choose very easily without making it too difficult. Maybe the cloud provider that you have is holding you to ransom. Maybe it's getting too expensive. Maybe you can't see how you can possibly remove yourself from those arrangements. And maybe wouldn't it be good to actually have the ability to say to one cloud provider, you know, I can move my workloads over here easily. I'm already set up for multi-cloud. I can do this easily. So what are you going to do for the pricing on this? Wouldn't it be good to be in that position? And of course, we've seen this. Clouds do go down. Parts of the cloud do go down. There are outages, very rarely, but they are there, and they will cause your business interruption. But if you're in a position where you've got more than one option and it automatically fails over, or you can move workloads very quickly, if you're set up like that, then you can increase your availability and make your business less susceptible to these failures. But it would be remiss of me to mention, or to not mention, why Google would be able to help you here. Of course, working for Google, I agree that this is obviously the best solution, but it's nevertheless, it's one of the options out there for you. But just a very quick summary on this. Maybe you want to look at Google because they're already experienced in providing 1 billion plus users per day on multiple platforms, and just YouTube is just one example of this. And we're a leader in the BigQuery, machine learning, and AI, and we've got customers that they'll come to Google first because of those workloads, because we differentiate and we've got the experience in that. And of course, all our platforms, our services are built on microservices and containers, and so they're ready. The platform is there ready for you to use Kubernetes, which we've heard of a lot today already. Commercially, we are, you can look at this as an advantage around billing and all of the arrangements around that in terms of our granular billing and the way that it's transparent, so it's not a secret. So got to compete with the other presenters today, and got to give you some diagrams that are at least fairly technical. So to give you one of 3 examples of how you could potentially implement multi-cloud. So example 1, probably the easiest one: split one application in one cloud, another application in another cloud. What it does is it gives you exposure to multiple clouds. Your DevOps teams will be encouraged to start learning more than one cloud and the configuration options and the nuances of each of them. But you've only got application A in cloud A, application B in cloud B, and they don't talk to each other. But it does give you a toe in the water of what multi-cloud looks like and learning skills, not just in one cloud. Then maybe you can move towards where you have the same application mirrored across multiple clouds and some kind of load balancing in front of it. And this will give you the option for doing version control, split across from, toggling from one cloud to the other, perhaps, and giving you that redundancy where if one cloud completely goes down, your application is still up. And then really moving towards the most complex, which is, think back to my quote at the beginning, where the customer has the best of both worlds, where they have multiple clouds and applications spanning across more than one cloud. And really, yes, it's more complex. Yes, you need to upskill in terms of how to manage that. But your application is going to be highly redundant with specific tasks in the cloud provider that is best able to provide that tool, and maybe the other tasks in another cloud provider where the tools are different and they're more suitable. And if the tasks and the application is connected in the back end, then you truly do have the best in terms of availability, the best in terms of tool sets, and potentially the best in terms of put your data where economically it's the best place to be. So Gartner predicted that 3/4 of fairly large businesses will have a multi-cloud or a hybrid cloud strategy. And we do see that now. More and more people are asking about how do they do multi-cloud? How do we manage it in the best way? And how do we make it as easy as possible? But Google, as you probably know, have got a lot of experience in application orchestration way back into the dark ages of 2003, where cloud was just a little raindrop, forming into our cloud. We had Borg, and then that developed, over time throughout these the early 2000s into where we are today. And if you see where we are in 2009, we launched Anthos, and this is where how do you get to the cloud really it becomes sort of something tangible. So with Anthos, not going to go into our presentation on Anthos. It's just a taster just to see how you could potentially do this. So Anthos gives you that ability to manage your workloads across multiple clouds and hybrid cloud environments. So neatly circumventing that perhaps thorny issue of trying to learn 2 or 3 cloud providers' nuances and configuration options. All you need to do is learn how to manage your workloads in Anthos, and it will do the work for you to manage the multiple cloud providers. And so you'll get consistency across all those clouds. You'll get one pane of glass to manage it, so you can see performance. You can be able to manage errors or down or anything that goes down. You can look at log files and so on. It's all managed within one management portal. So in summary, Google think as an open source kind of advocate, as a company that the strategy is to let their customers use or have a multi-cloud strategy. We want people to be able to have the choice of tools, the flexibility of where they're putting their workloads for the best price, and essentially have the ability to have that high availability option for you across multiple clouds. So thank you.
Awesome. Thank you, James. It's great. Let's add everybody back in here. Let's see who we've still got. Is everybody who's still here? Salman, Sandro, Dan, are you still around? Great. Yeah, that was great, James. I mean, I think, you know, it's what's definitely been interesting over the last, you know, 5 years or so is how these, you know, our abstraction layers give us the option of doing these things more and more easily, right? I mean, that's ultimately what Kubernetes lets you be able to do is, you know, abstract away everything that's running underneath and gives you a different layer that you can work in.
Yeah, focus on the application and what it does for your business rather than the details of how to do that.
Okay.
Even abstracted Kubernetes with autopilot, right? I mean, there's some really cool stuff that Google's doing. You know, cloud providers are stepping the hell up. It's beautiful seeing that, because who benefits at the end? The end users. That's the best part.
Yeah, autopilot's cool. It great takes away a lot of that guesswork and management. Yeah, and you can let it run.
So I think we've got a question from the audience here. If you use Anthos, aren't you tied into the cloud provider that hosts Anthos, or do you have HA for the Anthos pane you described?
You don't have to. You don't have to run it in GCP.
Awesome. Okay. This is an interesting one. I'm not sure whether you know the answer or would be prepared to say, even if it was true. Are Google multi-cloud themselves?
Not to my knowledge.
There we go.
And yes, I don't know whether they would say so.
Okay, and finally a question for Lewis. I think this is for. Is that your Christmas jumper?
Look, like, don't hate the PJ game right now. Like, this is the comfiest I've ever been in a meetup. Like, you just got to deal with it. It's you got to take the advantages that you can, and instead of having a Snapchat filter, I've just got a wardrobe of clothes I can change into whenever.
You actually can't see it, but I'm wearing PJs as well. I presented the first time ever a talk in PJs, and that counts.
More information than we need to know here, folks.
Well, we're starting something. If you look in the YouTube comments, something is starting. And it's a good thing, by the way. Oh, God, I'm just going to mute myself.
A pajama jammy jam, I think. Yeah.
Snooze ups.
Snooze ups. Oh, God. Right, on that
I've
note,
definitely attended some conferences that are a bit of a snooze fest. So
we're kind of getting to the end of today's proceedings. So I just want to thank all of our speakers, Pop, Salman, Sandro, Dan, James. I think that's everyone. Thank you, folks. And
can I give a shout out to you all? so amazingly organized. You all made me feel so at home with my UK brethren and sisterin. I appreciate you all, and thank you so much. I will return the favor. God willing, I'll be able to see you all in person at some point, but thank you so much. I appreciate it.
Thank you, dude. Much appreciated, and thank you for taking the time to come and join us. So thank you to my fabulous hosting team, Nick, Adrian, Guy, Lewis, and thank you to our sponsor, Sneak, who also pays my salary. I hold my hand up. And we've got some fantastic events in the pipeline. Please do join us on May the 6th, when Justin Garrison will be joining us live from Los Angeles. Justin is a developer advocate at AWS, has worked on Oscar-winning movies, is a fantastic speaker. So you are in for a treat there.
The Steven Spielberg of Cloud Native. Justin, shout out. That guy is fantastic. You all are going to be in for a treat. So that's on May the 6th. And Liz Rice will also be joining us in July. I don't think we've nailed down a date yet for that, Lewis, have we? But that's it's going to be some point in July. And we're working on a whole bunch of other fantastic speakers as well. So all the final thing is just to thank all of you for joining us.
Wait. Give us your lightning talks. So everyone from each of the different communities, give us your lightning talks. So we're going to wrap all these special guests up with an awesome selection of lightning talks that represent each individual community. So yeah, bring them on.
Yep, great. Thank you for that, Nick. Thank you for that reminder. I think that's pretty much it. Thank you for joining us. Don't forget to grab your Sysdig swag. I'll just put that banner up again very briefly so folks can get that URL if you missed out. And we will hopefully see you all on May the 6th. So thank you. Goodbye.
Cheers all.
Bye all.